Hi, good morning, everyone, and we welcome everyone on this Fundamentals of Virtualization session. And I would like to thank you, first of all, TDRA, for giving me this opportunity to present this session. It is a short, informative, and comprehensive session, and it's about the fundamentals of virtualization. So we are going to have, I will introduce myself first. My name is Sahibzada Ali Haider, and I have been a consultant engineer in this industry since 21 years and have versatile experience in the field of ICT solutions, services, auditings, and trainings. And I have been providing my services to different financial institutions, universities, armed forces, telcos, service providers, and have worked in the territory around the globe as well, and worked in Oman, Qatar, Saudi Arabia, in Europe as well. And I have planned and managed and executed 200 plus ICT project as well. Planned and managed executed 50 plus SLAs, conducting 100 plus trainings. And this is actually a quick introduction of myself. So in this session, we are going through the topic fundamentals of virtualization. That session duration will be 1 hour, and language will be English, and mode will be live online. And level, of course, it's going to be a session for an hour, so it's going to be a beginner's level. And we know that virtualization is a very vast technology, and it's not going to be covered in the 1 hour. But the fundamentals, I will try my best to cover each and every aspect of the fundamentals. So the learning objective after this session will be understanding of the virtualization technology, working principle of virtualization. Then obviously we will have understanding of the benefits and some pros and cons of the technology. Then application of the virtualization will be there. So we will go through some content that we are going through in this session, that we will be having first introduction to the virtualization. Then we will go through the virtualization architecture, what is virtualization, types of virtualization technology. We will see application of the virtualization, and in applications we have further applications that are server virtualization, network virtualization, storage virtualization, desktop virtualization. And we will discuss some advantages and disadvantages, and then conclusion, and then we will be having a small question answer session in the end. So as we all know that virtualization is basically a technology that is actually a demanding technology in this industry. And we will see that what is virtualization, how does it work, how does it help organizations better, greener in terms of their use of IT. Does it have any downside? Is it having another IT fad? That is actually we are going through in this session, and we will have, and we will find some all of these questions in that. And if we start from the virtualization, basically it is considered one of the hottest information or demanding information technologies of today world. And it is seen as one of the green ITs actually that help reduce infrastructure and maintenance cost. And it is regarded actually to be a cost-effective way to dramatically reduce downtime, increase flexibility, use hardware effectively, and reduce all overall system complexities. And like current virtualization technology owes its roots to virtualization in the mainframe environment in 1960s. Actually, I just wanted to let you know that it's actually old technology, but actually evolved nowadays after the emergence and after the evolution of the technology. So first it was introduced in the 1960s, and because of the need to provide isolation between users in time sharing systems, that actually where multiple users shared a single powerful systems, like mainframe computer in 1960s. And while reducing the ecological footprint, that actually was not a major concern of the organization of that era. That actually reducing the capital expenses, and mainframe computer were prohibitively expensive in that time. And as a matter of fact, only a few organizations could afford to have one in earlier in 1960s. And sharing that mainframe with multiple users from like hundreds to thousands was an expedient way to keep capital expenses down. And we can see here, virtualization is considered one of the most demanding information technology. And here you can see some uh, uh, diagram or layout of this virtualization technology. You can see here CPU, memory, network interface card, disk, and then we have this VMware virtualization layer, then operating system and application. We will see all these, that how it's happening and how it will be working. And if we talk about that, virtualization is achieved by inserting a layer of system software that are actually often called the hypervisors. But we will go through after that in a longer perspective for those hypervisor in upcoming slides as well. And if we talk about the organizations, like most organizations are facing new IT challenges. So the virtualization demand was there as businesses are evolving and growing, and in dynamic environment, you need to improve agility to keep pace with fast changing business needs. And sorry, and our employees, customers, and business partners are demanding more responsive service and more sophisticated applications. As you try to keep pace with new requirements and growing demands, our IT infrastructure is becoming larger and more complex, and putting more pressure on our IT organizations. And this virtualization helps actually in addressing our most pressing technology challenges. The infrastructure sprawl that's forcing IT departments to channel 70% of their budget into maintenance, and sapping resources of business building innovations as well. The difficulty stems actually from the architecture of today's x86 architecture or computers. They are designed to run just one operating system and application at the same time. And we know that if we have, like, we are using our laptops and we desktops and servers in our organization or in a domestic purpose, we know that we can run only one operating system at the same time. But virtualization have changed all this trend, that actually one operating system and application means that even small data centers have to deploy many servers for each operating system, and each operating system has just 12% of capacity, consumption as well, that most of the time they are always idle. So that's actually highly inefficient by any standard. And virtualization software solves this problem by enabling multiple operating system and application to run on one physical server or host. If you can see here, uh, that we have here operating system and application running here. So it means that we can have a better efficiency, and actually it is solving the problem by enabling multiple operating systems and application to run on a physical server host. And we will see that how it's going to be work. uh, like here, we have these virtualization architecture. There are actually two types of architectures available in virtualization, that are actually a bare metal architecture, hypervisor type 1 we call that, and there is another hosted architecture. But just to give you another overview or a little detail, that virtualization actually works at the heart of virtual machine. Okay, and that we will go through that virtual machine as well, that what is virtual machine. Basically, it is a tightly isolated software container with an operating system, just to give you an overview of that. And this hypervisor actually works over the layer of a system software, and that is also called a VMM. Okay, please note in your notebooks or memorize this, that hypervisor is also called a VMM. It's sometimes you will see in the practical field as well, in the industry as well, it will be written with the VMM. That is actually called virtual machine monitor. That is running between the guest operating system and the underlying hardware. And hypervisor, if you see hypervisor or VMM, that are actually both the same. They are talking about the virtualization layer. And in most common forms of virtualization, such a layer like a hypervisor or VMM is created by software emulation of the underlying hardware platform architecture. And a properly designed hypervisor provides application programs, an execution environment that is actually identical to its host hardware, and minimally it degrades performance and has complete control of system resources. And current hypervisors, that are hypervisor type 1 and type 2, that allows multiple operating system instances to run concurrently with the virtual machines on a single physical machine. And now we will go through that bare metal. If you can see here, that bare metal in this architecture, type 1 hypervisor or VMM is installed on bare metal hypervisor. Here you have a little overview here. Bare metal virtual machines monitors is installed. That you have here, your bare metal means hardware without any operating system running on that. You will be having a compute, you will be having a memory, network interface card, and these resources installed in that. And then you will not install operating system on that. You will be having this hypervisor or VMM. You can see here, virtual machine monitor, and that will be actually going to be run on this hardware. And then it will give you a resources to have a multiple operating systems, or give you a capability to have a multiple operating system running on this on these servers. And here you can see hypervisor communicates directly with system hardware rather than relying on the host operating system. It means that you won't have any operating system, like you don't install any Windows servers or any Linux operating system, or like SUSE or Red Hat. You will just have this small footprint. Small footprint means that it's small size in the file, a size of the file, that is actually going to be installed on this bare metal hardware, and then it will be giving opportunity or capability to have these virtual machines on your hardware. And here you can see here this actually the examples of that the vendors they are available. VMware ESXi, that is from the VMware. This is a type of hypervisor. Microsoft is offering a Hyper-V product, and Citrix actually offering a Zen. Basically, these all are the hypervisors, type 1 hypervisors. And please note and mark my words that these hypervisors, like type 1 hypervisor, is going to be used in the organizations, in the enterprises and in the data centers. That whenever somebody asks you that what kind of hypervisor or what type of hypervisor you are running in your data center, so that is actually hypervisor type 1. And there is another that is actually hypervisor type 2. We directly call it, that is actually for the domestic or for the lab purposes or for the demo purposes, that you install on your desktops, on your laptops. You can see here, host operating system is first installed. Host operating system means if you are using your desktops and you are having your laptops, you will be having some sort of operating system. That could be a Windows 10, that could be your Ubuntu, or any, like you are using that, but you have to have a normal host operating system on that. Then you will be having installation of, or you will be install a virtual machine monitor VMM or type 2 hypervisor. That I'm going to repeat again to have a clarity or differentiation, that type 1 hypervisor, this hypervisor is going to be installed or going to be used for the enterprise or for the commercial use, okay, for your organization. And this type 2 hypervisor you are going to be have installed, or you can install it on your desktops, your laptops, because it needs to be have a operating system installed on your computer, and this is called a hosted architecture. It is actually giving a self-explanatory explanation as well. Hosted architecture, that means that you need to have a host operating system, then it will have a virtual machine monitor. And you can see here a piece of software called a hypervisor or virtual machine monitor is installed on top of the host OS, and it allows users to run various guest operating systems within their own application windows. So this is actually going to be happen like once you will having your host operating system, virtual machine 1, 2, and 3. Actually, why I'm focusing here and why I'm taking much time here, because if you will get understanding about these like hypervisors and this bare metal and hosted architecture, obviously you are in, and you are going to understand the upcoming virtualization technology applications as well and everything. So type 2 is for the domestic use, and here you can see, and I hope many of you have already used and familiar with these VMware Workstation, Oracle VirtualBox, and Microsoft Virtual PC. And I'm pretty sure as well that many of you have like used that in your normal routine as well and normal life as well. Okay. So here, what is virtualization? Basically, virtualization is a technology that is going to be having uh, uh, transform hardware into a software, and it is actually it allows to run multiple operating system as a virtual machine, and each copy of an operating system is installed to a virtual machine. And we can see here that it's actually giving us an opportunity to have multiple operating systems running on this single hardware. You can see here that we have a server, then we have a VMware ESX, or we can have a Hyper-V. Actually, why I have drawn this picture here, and we have this because it's better have a better explanation that a server is there, then VMware ESX. It's not precise that VMware is only offering the services. You can have a Microsoft Hyper-V as well, then you will be having an operating system, and on top, you will be having application running on this hardware. And all the resources like this operating system, this virtual machine, or this container, you can see here, because we have not gone through the virtual machine, that I will just let you know that virtual machine is called a container. Like here you have a container as well, and this is having a separate operating system. So far you just need to understand that multiple operating systems, okay, I will actually call the name multiple operating systems, can be will be running, not can be, will be running on this single hardware at the same time. Okay, so this is actually the virtualization, and this is actually virtual machine that actually we are going to have again and again about this one. uh, Virtual machine, you can see isolated guest operating system installation within a normal host operating system. And a virtual machine is a compute resource that uses a software instead of a physical computer to run programs and deploy apps. So it means that the virtual machine is basically, it is your physical hardware that you are using right now, a physical server that is actually isolated from your physical hardware. And from the user's perspective, virtual machine is software platform like physical computer, that I wanted to say that that's a physical computer that runs operating system and apps, and everything is happening on a virtualization on the back end. You don't see anything that where this virtual machine is residing, and how it's gonna be work, and how it's going to be there. And just a second, let me put this. Yeah, and these virtual machines is basically happening through the hosted or hypervisor architecture. And this virtual machine actually having a further division of emulated or para virtualization as well. And we will see in the next that what are the types of virtualization technology. There are three primary technologies to achieve virtualization: emulated or full virtualization, para virtualization, and hardware virtualization. These are actually three primary technologies. So we are going through the emulated or full virtualization. Emulated or full virtualization involves a complete emulation of the underlying hardware platform that is actually based on the software, and particularly the hardware processors, instructions, set architecture for x86 processors. And this set of instructions relates to interrupt handling, reading, and writing to devices. uh, that is actually, you can see here that CPU, memory, network interface card, disk, these all resources will be shared across these operating systems. And these actually virtual devices are actually considered privileged instructions and can only be executed by the operating system of the underlying physical machine. And operating system must execute its privileged instructions that is actually going to be run on those operating systems, or these hypervisor. And under like this emulated or full virtualization, an unmodified operating system like binary and unmodified application binaries are executed, and the guest operating system, we can see there, this one is unaware of being virtualized and does not require any modification, though it is fully abstracted and decoupled from the underlying hardware by the virtualization layer. And hypervisor translates all operating system instructions in real time to have the desired effects on the virtual hardware, while user applications run unmodified. And it is basically considered the best three techniques to be provide isolation. That is actually like said by the VMware in 2007. And in full virtualization, for wider perspective, that operating system and its application can consume all physical memory and resource consumption management and performance isolation in a difficult way. And if the physical machine uses a CPU that is actually designed with the operating system virtualization, that is actually emulated virtualization, that is actually, that will work fine. And next we have here a para virtualization. A para virtualization actually approaches is a little different than the full virtualization technique. The guest servers in the para virtualization system are aware of one another. If you can see here, hardware hypervisor, then you have a virtual machine bus, then you will be have a root partition, child partition, and child. Actually, the difference between here, okay, that is actually giving you here direct access to the these resources. That is a full virtualization. You will having here a hypervisor. Here, if you will just see that we have a Hyper-V hypervisor that is actually offered by Microsoft. And what Microsoft does, that it is actually going to be have a operating system installed here, that will be any Windows Server 2008 to 2010, 2016, 19, okay, anyone. But you have to install that, and after that it will give you a capability to virtualize this hardware. And you can see here root partition, and child partition, and means that up to number of like it depends that how much storage you have. So root partition will be having Hyper-V. Windows Server, that will be Windows Server 2008 or anyone, like 2010, 16, 19, depends what you are running in your environment. And then it will be having a kernel, that device drivers, virtualization service provider. And then there will be a child partition. You can see here Windows client will be there, like that. It is going to be work like in this way, that once you will have this hypervisor on this hardware through the operating system, okay, that is actually called a para virtualization. Then hardware supported virtualization, you can see that is actually called you can call it a hypervisor 2 technology as well, because hardware based physical machine is there. You have a shared operating system and you have isolated server, that same hardware, same operating system. In this here you can see an OS level virtualization approaches does not use a hypervisor at all. Instead, the virtualization capability is part of the host, which performs all the functions of a fully virtualized hypervisor. So there are three kinds of hardware supported, that is actually having a shared operating system. Then we have a para virtualization, and we have a emulated. So these actually are the types of a virtualization technology. And now we will go through before going through this four major applications of virtualization, I would like to share a more information with you regarding the virtualization. That is actually that it actually helps in reducing the capability or reducing the inefficiency of your hardware system. And many applications you can run on each server, since actually each virtual machine encapsulates an entire machine. You can run many applications. It will help you in giving you a maximum server utilization, minimum server count, like every physical machine is used to its full capacity, and allowing you to significantly reduce cost by deploying fewer servers overall. Like if I will show you here, just gonna give you example here again. I'm going to take here. Okay, let's see that you are having like you have a Windows 2008, and you will be having a 2016, 2019. You will be running some Linux server. So just imagine that right now, how many of you are running, and how many servers you need to run those servers. Like you have, if you want to have a four operating systems or four servers, like Windows servers or your Linux servers, you need to have these kind of, or you are already having traditional hardware for each operating system. And honestly, many of you will be having idea that there will be a peak hours on that peak hours for to accessing that, like in the morning as well, and in the evening as well, or in the afternoon as well. But after that, most of your resources of this hardware is going to be wasted, because nobody is going to use them. And if you have, let's suppose you have a 64 gigabit or 100 and 32 or 256 GB of memory that is actually required by your database, or your software or your operating system is running on this bare metal single server, then how much time it is going to be used only on the peak hours. But on the rest of the time, on the rest of the time, this hardware will stay idle. But obviously it will be having resources of power, your racks, your cooling, and everything you need to plan for that as well. So let's now check that how much that this is going to be efficient and giving you advantages to have a to run a multiple operating systems that is actually going to be run on this single physical server. Actually, it is very easy, like faster, easier, and easier to deploy for the applications and resource provisioning. VMs are basically, like you can see here, they are self-contained software files that can be manipulated with copy and paste. This actually brings unprecedented simplicity, speed, and flexibility to IT provisioning management. So these are actually some benefits that you are going to have. We have a disadvantages as well, that you can see that you need some kind of first expertise on that. You need to have a first software cost on that. So there are a little disadvantages, but there it has a lot of benefits of doing that. That if I'm going to show you the benefits of that we are going to get through this virtualization, they are just, I'm gonna to just name them: reduce capital and operating system cost. It helps you in minimizing or eliminating the downtime, increase IT productivity, and fast provisioning of application and resources, greater business continuity, simplified data center management, availability of a true software defined data centers, you can have them as well. And by using these virtual machines, that is actually giving you opportunity to run on a single server, that is actually a thin layer of software that is actually running on your virtual machines, and it is giving you like key properties of virtual machines, that is giving you a partitioning capability, isolation, encapsulation, hardware independence as well. Like when we talk about a hardware independence, it means that provisioning or migration any virtual machines to any physical server. So just to give you another a good picture of virtualization technology. There are many benefits, but just I'm just going to share a practical experience with you, that if you are going to have this, so let's suppose you are having this hardware, okay, and you traditional hardware and running a one operating system on that, that is actually having a capability of that without virtualization. So just imagine that if you need to migrate, or you need to have this operating system, or your Windows server or your Linux servers, you need to move this from this server to another server, then you know that how much difficult it would be. And in old times it was not very easy to transfer or to copy that operating system or your server to the other servers during the disaster or during any failure. And just imagine that's giving you a little bit like a small piece of virtualization, that you can use this. By using a virtualization technology, you don't have to shut down, or you don't have to power off this server. You can move this virtual machine or this operating system or your server uh, uh, to another computer without powering off. That this is just giving you a only I'm just giving you a one example of that you can move. If you have to do a maintenance or upgradation to this server, you can move this server, that you are having all these virtual machines or all these servers, to the another servers to do some maintenance or upgradation. You can you imagine that that was actually not possible in the traditional hardware that we are using nowadays as well. And in like future as well, we will be using like that. There are some applications and some organization that actually they stay on the physical as well. It depends, but they are very less that in the organizations or in the industry that they are having that traditional physical servers and running a single operating system on the single hardware. So types of virtualization, if we talk about, there are four major applications of virtualizations are running, that are actually server virtualization, network virtualization, storage virtualization, and desktop virtualization. These are actually very famous. And if we talk about the server virtualization, we can see here it's creating multiple logical servers or OS instances on one physical piece. And server virtualization basically enables multiple operating systems run on a single physical server, which I was explaining you before as well. And it is actually providing you highly efficient virtual machines. And the key benefits like greater IT efficiency, reduced operating cost, faster workload deployment, increased application performance, higher server availability. That is actually going to be eliminate server sprawl and complexity as well. You can see here traditional server architecture, one operating system and one application or multiple application can be running on that. But obviously, this is a traditional server architecture. But in a virtualized server architecture, that you will be seeing that virtualization layer. Now, like a question to all, that this virtualization layer means that I hope everybody have answered my question as well, that what is this called, like virtualization layer. So it means that some kind of hypervisor is running on this hardware, like on server. And this virtualization layer is a type 1 when we talk about the enterprise or corporate sector in a commercial point of view. That is a hypervisor type 1, and you are running a operating system on that, and then you will be having that application on that. So this is a server virtualization. So when we talk about network virtualization, that is actually referring to the abstracting network resources that were traditionally delivered in hardware to software. And network virtualization basically by completely actually it reduce a physical network, and network virtualizations allows applications to run a virtual network as if they were running on a physical network. Just giving you an example here, the coding just to give you an understanding. Here you have a one network interface card in your server. Here you have another network interface and this another server. So network virtualization is giving you an opportunity to have a virtual switch that is going to be, I'm just going to put some numbers, 1024 ports on this physical network interface card. Okay, just actually it will be difficult to understand for you right now that, but I will try my best to let you know that a single network interface card that you are having on your server can give you a capability of a virtual switch that is actually having 1024 ports. Means to you can have you can connect 1024 virtual machines with this virtual switch, but physically you will be having a one network interface card. So this is actually the beauty of the network virtualization, that is actually a completely reproducing a physical network. And with this great operational benefits, like all the hardware independence of virtualization, it presents a logical network devices and services, and logical ports, logical switches, logical routers, firewalls, load balancers, VPNs, and you can have all the capability on this switch. If you can see here, this is basically a virtual switch on your top of your this physical network interface card. If you can see here, it's written here, network NV, network virtualization can combine multiple physical networks to one virtual software based network. And here you can see on the right side of this diagram, virtual machines. Then you have a virtual network adapters that you can see here, you can have of each your virtual machine. Then virtual switches, that is actually on the top of your physical network adapters and local area networks. It means that here you have this cloud representing a physical switch, and that is actually connected to your network interface card. But inside, like by installing that hypervisor layer, that you will be able to have this virtual switch in that. And then obviously every virtual machine will be having a multiple operate like network interfaces cards, as well as we have a limited options there, that we can have some some like VMware, some vendors are offering different on a different version as well, that what kind of version you are using in your corporate sector, like network 64 uh, uh, or 32 or 16, or it depends that what kind of version you are running. So these are the actually benefits of your network virtualization. Next we talk about okay, what is this? Just a second. No, it's not that. Sorry to have little clinch in that. Okay, sorry. So network virtualization is there. So on a storage virtualization, if we talk about that, this is going to be basically in storage virtualization. It is going to help you in virtualizing your storage portion. Like if you can, I'm just going to tell you about storage virtualization in a quick way, that storage virtualization is basically required a rapid growth of stored data that is actually created a demand for storage systems, and that can be expanded without shutting down systems or without regard to the number of physical disks supporting the storage system. And using virtualization software, storage drives can be added, uh, can be added or replaced. uh, okay, I think we lost the share. I'm going to share it again. Sorry for this clinch. Yeah, I'm back here. So storage virtualization is basically actually it is a virtualize. It is also using a virtualization software that is actually drives by the software that is actually added or replaced or replicated by the backup, snapshot, and mirrors, and it can be created without incurring downtime. and it increases productivity of IT professionals by allowing them to centralize many storage related maintenance. And it creates basically an abstraction or virtualization layer between storage clients or host and physical storage that hides the basically individual storage devices like physical devices from that. And in other words, if we talk about the storage virtualization, that is actually it abstracts logical storage from physical storage so they can be shared among a number of servers and applications. And according to we like seen in the real world, we have some technologies that are called a RAID as well. If you know about the RAID, that is actually RAID, that is redundant array of independent disks. Actually, that is actually combining your physical hard drives into a one logical or one storage or data store that is actually be going to be provided you on the on your databases or with your virtual machines. And now desktop virtualization, that is actually we have seen this nowadays in everywhere, in the banks, in the large organizations. Basically desktop virtualization is relatively new compared to the other application like server virtualization and network virtualization. It involves providing end user with a desktop environment that allows access to any authorized application without regard to the location of the application. There are actually two primary architecture of desktop virtualizations: client hosted and virtual desktop, like VDI. You will see in your real time VDI, that is actually a virtual desktop infrastructure, and a client hosted, like there are two types. But in the market and in everywhere in the corporate sector, you will be having this VDI technology, that is virtual desktop infrastructure. In virtual desktop infrastructure, or in a first we will talk about the client hosted desktop virtualization architecture. A separate operating system environment is created at the client's end, okay, and allowing incompatible legacy applications to operate within their native architecture. And desktop operating system and applications are running in the virtual machines on data centers. And this is actually part of our VDA as well. Desktop operating system inside virtual machines are also referred as a virtual desktops. And like using a remote display protocol, users connect to these virtual desktop from their PCs. I'm just going to elaborate this desktop virtualization to you, that you will be having a small device like this is that is called a thin client, okay, thin client, a small box with not having any kind of operating system installed on that operating system means that you will not be having a Windows XP or Windows 10 or Windows Vista, or these you are not running on that, okay. You will be having a thin client that will be having interfaces, that will be Ethernet interface on that, and that you will be having some USB ports on that. And all your operating systems, like your virtual machine or your operating system, will be running in the data center that is going to be somewhere else in the world or in the city or in your building as well. But all the data or all the signals or all the data will be connected or will be sharing through the Ethernet. And what is the benefit? Actually, the all the big and organizations and enterprises are going to be uh, uh, like um, uh, migrate or going to be move from a traditional desktop to the desktop virtualization due to a lot of benefits. Like the first benefit I will give you, I will let you know that in desktop virtualization you will be having a highly security on your data. Like you don't have to have a hard drive physically available in your desktop. Like you know, you won't be having a physical machine running or having on in your organization or on your desk or your within your user. Nobody can get the data, or nobody can have stole or steal that data from your desktop. So this desktop virtualization is basically the future era or future of the industry. So it actually enables consolidation of multiple desktop workstations onto a single server, and resulting into a significant reduction in overall power consumption, and allows a user to access his or her equivalent desktop from any endpoint. And desktop virtualization using VDI basically enables the reach of business continuity and disaster recovery to the desktop, and it can strengthen an enterprise IT security by eliminating the need to store data on laptops or PCs and storing it on the data center servers. That is actually helping and reduce cost to the to administer and maintain laptops or PC. You will be not having maintenance cost as well, because there will be no hardware available on your thin clients that I told you about. That thin client, that is a small box that will be having only a USB ports and a Ethernet port, and that will help you in reduce power consumption by replacing high power consuming laptops and PCs with energy efficient thin clients. Okay, and that is actually providing you a flexibility to an increasingly mobile and widespread workforce as well, and providing centralized backup to guard against data loss or corruption. That is actually enabled by a central administration of desktops from any location in the world. Scalable management is there, that is actually allowing and storing and managing thousands of virtual desktops on hundreds of physical servers. And from a single management console, like it is helping you to manage all your virtual desktops, and that is actually helping us streamline provisioning, allowing new desktops in minutes instead of days or weeks, and desktop isolation. And the virtualization market is basically dominated by VMware. That is actually provides many virtualization products for server virtualization, storage, network, application, desktop, IT infrastructure virtualization. There are more as well, but actually VMware is focusing and is actually having a lot of research and a lot of top brand or top quality product in the world as well. The other top vendors in the industry are also there. That they are Citrix, Novell, Microsoft. I told you Oracle. Sun is also providing you the virtualization products. Citrix actually provides application servers and desktop virtualization that is based on the Zen platform, and that is actually a para virtualization. And Novel, that is actually primarily uses para virtualization technology, and Citrix using a Zen based virtualization that is focusing on the server virtualization. And it actually also supports hardware assisted virtualization with AMD processors. Microsoft provides server, storage, application, and desktop virtualization that is actually using both full virtualization and a hardware assisted virtualization. So if we talk about the benefits of the virtualization that I have already told you, in a small way, in a quick way, that actually helps you in reducing your power consumption, user mobility, lower cost infrastructure, lower carbon emission, rapid provisioning, real-time deployment of live resources, application testing, business continuity, and streamlined backups and mirroring. And it is actually enabled the creation of global virtualized infrastructure. So these are actually the benefits of some of virtualization. You can see thousands of benefits once you are going to use that and you are going to implement in that. And the most required in the companies organizations is disaster recovery and business continuity. That is actually the key factor or key requirement for all the companies or all customers or all corporate sectors. That it is actually providing your business continuity during planned or unplanned outages by transparently redirecting. It will provide you a high availability. I will add some kind of words or kind of vocabulary to you, information that high availability HA redundancy is there. You can move or you can migrate your virtual machines not within the data center as well. You can have geographically, you can move from one country to another country without any downtime. And there are some and that actually is going to be achieved by some technologies VMware is offering through the vMotion, and Hyper-V is have its own migration, is like Citrix is having its own technology. So these are actually a lot, there are a lot of benefits in the virtualization. So as we know that it's going to be a future as well, it's like evolution is there, and we are on the right era as well. It is providing us a business agility, better security, more reliable, less costly, and testing and deployment as well. And the overhead actually, the like it's the cost of the virtualization, that if we see or compare that with the traditional versus the virtualization, and upfront in start, that we will be having some extra cost. But actually the disadvantage that we normally see is the expertise, that we need to have a certain trained people for that as well. But after, like once we have that, we will be having a lot of benefits in that as well. And like now let's go to the, that it's going to be end of the session. We are going to have a question answers on that, and I will love to answer your questions, and I'm waiting that we will be having some questions here. So if you have any question, you can ask, and I will love to answer that, because we have 10 minutes left to discuss and to have this session ending. Yeah, it's actually like I'm just as let's see uh, that questions will come up. That in the meantime, I will just share some my practical experience with you, that virtualization is an awesome technology, and it's a future, and we must understand, we must start it with like by any means. We can start it from, like I have given you some overview, that it's a 1 hour session, and I try my best to cover the technologies as well. And the question is, uh, the first question is that a virtualization used by single user in a small scale, or it is used by a big organization. Basically, I have told you that uh, there must be selection, that you have two types of hypervisor. That single user means you need to have a type 2 hypervisor, that is a VMware workstation. You can install it on your laptop, on your desktop. But if you are talking about a big organization, you are going to have a type 1 hypervisor. They are, I told you, ESXi, Zen from Citrix, and there are other market. But single user means that type 2, that is for the domestic purpose. Okay, for big organization, that is type 2 hypervisor. Okay, so that is on a commercial base. And can virtualization used by single user in small scale? Yeah, again, how many have used? Okay, yeah, workstation virtual box. Okay, so like it's a very good question. That single user mean that for domestic purpose, like for demo purpose, for lab purpose, that you want to use a multiple operating systems for some kind sort of demonstration, some sort of lab preparation. So you can have a single user on type 2 hypervisor. And I have showed you that, and I am telling you, VMware Workstation is the good example of single user. And from small scale, that if you want to have a commercial use, small scale or large scale commercial use, when talk about organization, you will be using a type 1 hypervisor, that are ESXi in VMware, in Citrix they are Zen, and you have other vendors as well, in Microsoft, that is Hyper-V. Yes, of course, virtualization can be used by a single user or multiple users. And as uh, I have already asked, that many of you must be using or have used once in your life your hypervisor 2, that is a domestic, by for lab purposes or for any demo purposes. We have a question: is it beginner friendly, or do you need to have in-depth knowledge before using? No, actually, the Type 2 hypervisor, anybody can use that. It's beginner level. There is no beginner or expert or uh, uh, medium level, or beginners, intermediate or expert level. Sorry for intermediate or expert. That type 2 hypervisor, you will have installation on that, and you will learn. There will be some help within that hypervisor as well. Once you install that, and it will give you, and you do not need a lot of expertise in that. But obviously, if you go through, I strongly recommend that you must install the type 2 hypervisor on your desktops or laptops before going to the type 1 hypervisor, because it will give you a lot of information or knowledge about your virtual machines. You will understand that how it is going to get the resources, and how you will be running multiple virtual machines on that. There will be a lot of information that you will get, and you can proceed to the next level, that is type 1 hypervisor in your organization. So it's very easy, that GUI based, not CLI based, user friendly. All, like if we talk about the type 2 hypervisor and type 1 hypervisor, they are actually all a GUI based and user friendly, that you can have understanding in a very quick way. As quickly you can understand, you can learn. But I recommend you that you go with the type 2 hypervisor for your demo, for your understanding. And depth knowledge, obviously you need it for doing multiple tasks or multiple operations. It depends that what kind of benefits or what kind of usage you are going to have with that hypervisor or that virtualization platform. So more questions? Okay. Uh, I think it's the session is going to be like, we just have a 2 minutes left. Thank you so much, all of you, for attending and for giving your prestigious time, a precious time to have this session. And I would like to thank again TDRA for providing or giving me this opportunity to uh, present or to deliver this short informative and comprehensive session on the fundamentals of virtualization. Thank you so much for your time, all of you. Take care. Best of luck for your future and all the best. Thank you so much.